Well, in last class, we have studied some condensation reaction. Actually, its in all mechanism is different. It is nucleophilic addition and elimination. Totally condensation reaction. So, elimination of water takes place with derivative of ammonia. So, aldehydes and ketones undergoes nucleophilic addition and elimination reaction with derivatives of ammonia. So, we can write derivatives of ammonia as NH2Z. So, this Z may be OH, this Z may be again NH2, this Z may be C6H5 NH, or it may be C6H5 NH NO2 or it may be it is NH2 CONH. So when it is OH, it is called hydroxylamine NH2OH. When it is NH2, when Z is NH2, its formula is NH2NH2 called hydrazine. So when it is NH6H5, we know this is called phenyl and this one is called hydrazine, so it is a phenyl hydrazine. This is 1, 2, 3, 4. So it is 2, 4 dinitrophenyl hydrazine. And this one is semi-carbazide. So as given some reactions in last class, reactions are with hydroxylamine, the product is called oxime, with hydrazine, the product is called hydrazone, and phenyl hydrazine, the product is called phenyl hydrazone. I think in the last equation has not written the phenyl hydrazine group. So it is RCHO, then NH2, afterwards it's NHC6H5. Elimination of water takes place. That is mechanism, we don't have the discussion of mechanism of this reaction, but actually it is a nucleophilic addition and elimination. So I am showing directly the elimination of water. The product is RCH double bond NHC6H5. We know this is called phenyl hydrazine, so it is phenyl hydrazone or it is aldehyde phenyl hydrazone. Aldehyde phenyl hydrazone. Suppose aldehyde is CH3CHO, we know it is called acetaldehyde. Then with phenyl hydrazine, the product is acetaldehyde phenyl hydrazone. So formula is CH3, then it is CH double bond N, NH, and afterwards we have C6H5. So one more product is water elimination of H2 takes place. So it is acetaldehyde phenyl hydrazone. Aldehyde is acetaldehyde phenyl hydrazone. Phenyl hydrazone. Well, if it is ketone, we know the formula for ketone RC double bond O R or R dash. Both are identical. Then we can write for both R. If it is different, you have to write R and R dash. And phenyl hydrazine NH2 NHC6H5. So no need to draw the benzene ring. You can write the formula C6H5 itself. It shows that there is a benzene ring for this formula. We have RCR double bond N NH C6H5 and H2O. So So like in case of aldehyde, this is also it's a ketone phenyl hydrazone. Ketone phenyl hydrazone. Phenyl hydrazone. Then it is, you can write example. Simple example is acetone. You know CH3, C double bond O CH3. Then we have NH2, NH, C6H5. Elimination of H2 takes place. The product form is, we know it is acetone phenyl hydrazone. Acetone phenyl hydrazone. This is the product. Acetone phenyl hydrazone is the product. So the phenyl hydrazine product is phenyl hydrazone. Afterwards we have 2,4-DNP. It's also called 2,4-dinitrophenylhydrazine. That's the full form of 2,4-DNP. 2,4-dinitrophenylhydrazine. The reagent is 2,4-dinitrophenylhydrazine and the products are it's a 2,4-dinitrophenylhydrazone. Well, with 2,4-DNP or with 2,4-dinitrophenylhydrazine. So it is with 2,4, 2,4, it's not 24, 2,4 dinitrophenylhydrazine. Phenylhydrazine. So aldehydes and ketones, aldehydes and ketones react with two,4 dinitrophenylhydrazine, phenylhydrazine, dinitrophenylhydrazine to give, so I am writing here 2,4-DNP. This is also called 2,4-DNP to give 2,4-DNP or dinitrophenylhydrazine. So what you have to remember, the formula hydroxylamine H2H, product is oxime. Formula for hydrazine NH2, NH2. In general it is NH2Z. You have to write, remember what is meant by Z for different reagent. OH for hydroxylamine, NH2 for hydrazine, and for phenylhydrazine it is NHC6H5, and then for 2,4-DNP, NO2 groups are on the second and fourth position with respect to the NH. So it is NH2, NH, then we have C6H3, NO2 twice, means NO2 are at 2 and 4th position. So product is, in case of hydrazine, hydrazone, phenylhydrazine, 2,4-DNP, it's a 2,4-dinitrophenylhydrazine. Well, I am writing the formula for aldehyde RCHO. So 2,4-DNP, we cannot write condensate formula because you have to show the NO2 group on second and fourth carbon of the benzene ring. So you have to write the complete formula only, NH2, the expanded formula, NH. Then we have benzene ring on the second and fourth carbon atom of benzene ring. We have NO2 group, that is 2,4-DNP. Product is, so getting the crystalline precipitate, orange or sometimes yellow-orange crystalline precipitate of 2,4-dinitrophenyl hydrazone, NO2 and NO2, one more is 62. So product is aldehyde, same thing as we are studied in case of hydrogen and vinyl hydrogen, aldehyde 2,4 dinitrophenyl hydrazone. Phenyl hydrazone. Well, I am writing an example here. HCHO. So what is HCHO? It is a formaldehyde. Okay, one carbon, so it is a formaldehyde. Formaldehyde. Then 2,4-DNP, NH2, NH. We have a benzene ring. On the second and fourth carbon, we have NO2. So it is 2,4-DNP. Elimination of H2O takes place. H2O get eliminated. The product is H, then it is CH, double bond N, NH, and then we have a benzene ring with NO2 on second and fourth carbon atom of benzene. So product is formaldehyde 2,4-dinitrophenyl hydrazone. Formaldehyde 2,4-dinitrophenyl hydrazone. Phenyl hydrazone. 2,4-dinitrophenyl hydrazone. Then ketone. We know the formula for ketone. RC double bond OR plus it is 2,4-DNP NH2 NH. You can draw like this also. No need to show the below the nitrogen. In the same direction you can write. On the second and fourth carbon we have NO2. So elimination of H2O takes place. The product obtained is R double bond N NH. Then we have benzene ring NO2 on second and fourth carbon plus H2. So it is ketone, like aldehyde, it is ketone 2,4-dinitrophenyl hydrazone. Phenyl hydrazone. Then we have one more reaction, example. Example is a stone, simple example you have to write, and even for the board exam also we have same type of question. A simple question we have for simple aldehydes and ketones. So it's ketone means acetone plus it is 2,4-dinitrophenyl. 2,4-dinitrophenyl hydrazine or 2,4-DNP. Product is it is CH3, CCH3, double bond N, NH. Then we have a benzene ring. NO2 group are on second and fourth carbon. So what's the name of this product? Simple. It is like aldehyde, acetone 2,4-dinitrophenyl hydrazone. Acetone, then 2,4-dinitrophenyl hydrazone. Well, here This bond is not linked to hydrogen. It is linked to the nitrogen. We have NH, then that nitrogen linked to the aromatic ring or benzene ring. So it is about the 2,4-dinitrophenyl nitrogen. Totally we have with hydroxylamine, hydrogen, phenyl hydrogen, 2,4-DNP and semi-carbazide. So let us discuss about with semi-carbazide. Reaction with semi-carbazide. What you have to remember? Only two things. One is oxide and another is ZONA zone. That is, if it is hydrogen, hydrogen. Phenyl hydrogen, phenyl hydrogen. If it is 2,4-dinitrophenyl hydrogen, then 2,4-dinitrophenyl hydrogen. And if it is semi-carbazide, semi-carbazide means for hydrogen derivatives, it is ZONE, hydrogen nitrogen, like that. If it is OH group, hydroxylamine, then the product name is oxide. That thing you have to remember. And it's very easy to write the equations. Just you have to remember NH2 and Z. What's Z you have to remember? Okay, with semi-carbazide. Semi-carbazide. So formula for semi-carbazide is NH2, NH, This is the formula for semi-carbazide. So product is semi-carbazone. Aldehydes and ketones react with aldehydes and ketones react with semi-carbazide to give semi-carbazole. Such semi-carbazide. We know the formulas for semi-carbazide: aldehyde RCHO, ketone RCO R dash or RCO R. Semi-carbazide, and it is aldehyde. So aldehyde RCHO is aldehyde semi-carbazide. Remember, in semi-carbazide, both terminal contains NH2. That means on this side also NH2 and on the right hand side also we have NH2. Remember, only that hydrogen get eliminated. The hydrogen which is attached to the nitrogen, and the nitrogen must attach to NHCO in NH2. Not right hand side hydrogen involved in elimination, or the hydrogen of NH2 not attached to CO involved in elimination. If it's attached to CO, then that hydrogen do not get eliminated in the reaction. This point you have to remember. Which one? This one, not this hydrogen. So aldehyde, NH2, then NHCO, NH2. In this form also you can remember NH2, Z, derivative of ammonia. So that Z group do not involved in elimination. Only NH2 group involved in elimination. Hydrogen of NH2 involved in elimination. So this one involved in elimination. So this is semi-carbazide. Product formula is RCH double bond N NH CO NH2 and H2O. Such as semi-carbazone, aldehyde semi-carbazone. Example. I am writing benzaldehyde C6H5CHO. Instead of writing the benzene ring, you can write formula C6H5. It's a phenyl or benzene ring. And NH2, NH, CONH2. So this H2 is not in elimination. The product is C6H5, then it is C6H5 CH, C6H5 CH, double bond N, NH, CONH2 and H2O. So product is benzaldehyde. This is benzaldehyde. Benzaldehyde. Product is benzaldehyde semicarbazole. Benzaldehyde semicarbazole. Benzaldehyde semicarbazole. Now for ketone, R C double bond O R, then it is NH2NH, CONH2, H2 will terminate. Here also have double bond. Remember, it's a carbonyl group. CH double bond O. It's not linked to the hydrogen. Oxygen is attached to the carbon. So product is R C double bond R. Now here double bond to the nitrogen N, NH, CO, NH2 and H2O. Like aldehyde, it's a ketone semicarbazole. Ketone semicarbazole. Semicarbazole. Example, I am writing acetophenone, C double bond O. In case of acetophenone, C double bond attached to the phenyl or benzene ring and CH3. So it's a phenyl C6H5, then CH3. Plus semicarbazole NH2, NH, CONH2. Elimination of H2O takes place and the product formed is C6H5, then it is C, CH3. Afterwards, we have double bond N, NH, CO, NH2 and H2O. So we know what is called ketone means acetophenone. This is acetophenone. Acetophenone. So product is acetophenone. Acetophenone semicarbazole. Semicarbazole. This is the product. Well, this is about not condensation actually. This reaction is nucleophilic addition, elimination reaction. So if question comes for competitive examination and option is one of the option is condensation and one more option is nucleophilic addition and elimination, then you have to the correct answer for that one is nucleophilic addition and elimination reaction, not condensation. Well, condensation in general we used to say whenever the two molecules get combined or get interacted, there is elimination of small group like water or ammonia etc. small group during the reaction, then it is called condensation. So in general we used to say condensation, but it is not a condensation reaction. Well, afterwards it is about oxidation reaction of aldehydes and ketones. As we know, aldehydes are more reactive compared to ketones because in case of two effects already were studied. One is the carbon is attached by two group, hydrocarbon group in case of ketone. So there is hindrance. Due to steric hindrance, they are less reactive. One more is electronic effect. There is a repulsion due to large number of electrons. So compared to aldehydes, in case of aldehyde, one carbonyl group is attached to one hydrocarbon group and one more is hydrogen. There is no two bulky group. One is hydrogen, small group, small atom it is. So it is more reactive. Well, in case of oxidation reaction also, aldehydes easily undergo oxidation. Even with mild oxidizing agent like tolerance reagent and also pairing solution, aldehydes easily undergo oxidation to give carboxylic acid or carboxylate ion. If you are adding tolerance reagent, it's ammonical silver nitrate into aldehyde, then you are getting black color PPT of silver or what? Or aldehyde. If it is pairing solution, the sodium potassium tartarate, copper sulfate with NaOH, that's called pairing solution. If you are using pairing solution, then the product formed is a red color precipitate of cuprous oxide. That means you are getting coloring substance. So these two reactions, which reaction? Reaction with tolerance reagent and with the pairing solutions are used to distinguish between aldehydes and ketones. So ketones do not use black precipitate with tolerance reagent and also do not use the red precipitate with pairing solution. Only aldehydes use, answers the test for the tolerance reagent and pairing solution. So we can use these two reagents to distinguish between aldehydes and ketones. In both reaction, aldehyde undergo oxidation to give carboxylate ion or to give the carboxylic acid along with the PPT. Well, let us discuss about oxidation reaction. I think you are followed. One more time I used to say, see here, in case of aldehydes and ketones, as we know, aldehydes are more reactive compared to ketones. The reason is, one is electronic effect and second one is steric hindrance, that is bulky group. Well, ketone do not easily undergo oxidation. It undergo oxidation but not easy to oxidize because of that bulky group attached to C double bond O. So ketones do not undergo the oxidation easily, but aldehyde easily undergoes oxidation even with mild oxidizing agent. So example for mild oxidizing agent, it is ammonical silver nitrate or tolerance reagent and one more is pairing solution. So these two are the mild oxidizing agent. In case of pairing solution, you are getting red color precipitate of cuprous oxide and aldehyde is oxidized to, it is carboxylate ion or carboxylic acid. If it is tolerance reagent, it is called ammonical silver nitrate. If it is tolerance reagent, then you are getting black precipitate of silver and aldehyde is oxidized to carboxylic acid. If it is pairing solution, it is copper sulfate and sodium potassium tartarate with NaOH. You are getting cuprous oxide and one more product is, it is carboxylic acid. So what you have to remember, pairing solution is reduced to cuprous oxide. Then tolerance reagent is a silver oxide complex form reduced to silver. So oxidation reaction of aldehydes and ketones. Oxidation reactions of aldehydes and ketones. Oxidation reactions of aldehydes